Hi all, today we are going to see about a minimization of DFA in compiler design. Minimization of DFA. The algorithm for the minimization of DFA is just as follows. Input, it is a DFA. Output, it is a minimized DFA. Step 1, draw a table of all the pairs not necessarily connected directly. Step 2, consider every pair in a DFA where Qi belongs to a final state and Qj that does not belongs to a final state, that is a non-express state, or vice versa, and mark them. Step 3, repeat this step until we cannot mark any more states. If there is any unmarked pair, that is Qi and Qj, mark it if it is a pair, that is the transition of Qi with an input A and the transition of Qi with the same input A is marked with some input alphabets. Now step 4, combine all the unmarked pair Qi and Qj and make them in a single state in a reduced DFA. Let's see an example for the minimization of DFA. This is shown example where A, B and F are the non-accepted state, C, D and E are accepted states. Once the first step of minimization of DFA, it has been starting with construction of a DFA table. DFA table contains the number of states and the column consists of the number of input symbols, that is 0 and 1, and it has been filled over here with the table. And this is a table filling algorithm for the minimization of DFA. Here, row wise, all the states has been taken row wise and column wise. The row wise, this first state, that is A, is to be omitted, and while taking the column wise, the last state is to be omitted. The table filled row wise does not contain the first state, and the table filled column wise does not contain the last state. The table is filled using two symbols, that is a tick mark and the cross mark. The tick mark that represents the states are equivalent and the cross mark that represents the states are distinguished. And now we have to find the pair of accepted and non-accepted states. In the above shown DFA, the states C, D and E are accepted states and the remaining states are called as the non-accepted states. Now take the pair of accepted and not accepted state, and all those states are to be marked as distinguished, that is with a cross symbol, because always when we consider for the minimization of DFA or equivalence of DFA, an accepted state will be paired within another accepted states, or the non-accepted states will be the pair within another non-accepted state. Hence, only those states will be equivalent, and the other cases, the accepted and the not accepted states will be equivalent. Now, reduce the number of steps. The first, to reduce the number of steps, the first step we take the pair of all the accepted and non-accepted state which are distinguished, and we mark a cross symbol in the table. And now we will try to make the state pair. If we input 1 to the state A and F, it will go to the state C and F respectively. That is, it is already marked. Hence, we will make the pair A and F. Now, we input 1 to be state B and F. It will go to the state D and F respectively. D and F is already marked. Hence, we will mark the pair B, F. This is to be followed for all the pair, and the same set of inputs are given for every pair. For example, we will take a pair from the given example A, B and give 0 as an input. While giving A for the state A, we are giving 0 as an input, it goes to the state B, which is a non-accepted state, and the same input should be given to the state B, which goes to the state A, which is also a non-accepted state. We have to consider whether the both output goes to non-accepted states or accepted states. If both goes to the non-accepted states, now we mark a tick symbol and we say that the given state is equivalent. Else we'll mark it as a distinguished states. This is to be followed for all the several inputs, like giving 0 as an input and next 1 as an input and 1 0 and 0 1 and 1 0 0 for all the pair. Hence we state all the states are equivalent and the minimized state and made as a pair. For the previous shown example, the transition table for the minimized DFA is shown below. This is how it has been reduced. Here A and B, that are the two non-accepted states, are been paired and it has been taken as a single state which has been minimized. Here the C, D and F, these are the three accepted states, and these three states have been minimized using the previous algorithm, and it has been equivalent and it has been marked over here in the table. And the state F, it does not pair with any of the state, so it has been shown single. This is the transition diagram for the previous shown example, and for the given question, this is the solution for the answer. This is the reduced or the minimized DFA. Thank you.